Arithmetic progressions. Arithmetic progression is a series in which the new term is the difference between two consecutive terms such that they have a constant value. The series is identified as an arithmetic progression with the help of a common difference between consecutive terms. The consecutive terms vary linearly. Arithmetic progression has the same common ratio throughout. Arithmetic progression does not have common difference, and a new term is the product of the previous term and the common ratio. An infinite geometric progression is either divergent or convergent.
Problem statement 1. Encik Suhaimi is a chicken breeder that has 1,500 chickens. He planned to sell 200 chicken each day. He give food to all chicken with the expense of 50 cents per chicken in a day. Calculate the total expense of the food spent by Mr. Suhaimi if he starts with 1,500 chickens until he is left with 300 chickens. Fill a table. For the fact, we know that Encik Suhaimi is a chicken breeder that has 1,500 chickens. For the idea, we need to understand the questions. The second one, we need to form an arithmetic progression series. The third one is implementing the arithmetic progression series. And lastly, write a conclusion based on the answer. For learning issues, we can know about which progression is used for the questions. And the second one, which formula is used for the calculations. The third one, what is the keyword for the problem. And lastly, forgot to follow the step to solve the questions. The resources needed is internet and textbook.
Assalamualaikum warahmatullahi wabarakatuh. I'm Hanif Naufal bin Muhammad Hassan. Now I will solve question 1. For the step 1, we must know the rule of writing the pattern of the sequence is below. The formula is Sn equal to A plus D times N minus 1. First term is A and the second common difference is D. D equal to S n plus 1 minus Sn. Then we go to the step 2. We get the value is 1,500, 1,300, 1,100 until 300. And we get A is 1,500 and D minus 200. Now we apply the value to a formula Sn equal to A plus D times N minus 1. After we apply the value to the formula, we get 300 equal to 1,500 times minus 200 times N minus 1. And then we get 300 equal to 1,500 minus 200 and plus 2. For the 1,500 plus 200, we get 1,700. Then we simplify. After we simplify, we get N equal to 7. Now we go to the step 3. On the 7th day, the number of chicken left is 300. Now we apply the value to a formula sum. S equal to 7 over 2 bracket 2 times 1,500 plus 7 minus 1 times minus 200 and close the bracket, and we get 6,300. Now we go to the step 4, the last step. The total cost of a grocery shopping is 6,300 times RM 0.5, and we get RM 3,150.
Geometric progression. Geometric progression is different with arithmetic progression. Geometric progression is defined as the series in which the new term is obtained by multiplying the two consecutive terms such that they have constant factor. This series is identified as a geometric progression with the help of a common ratio between consecutive terms. The consecutive terms vary proportionally. Geometric progression does not have a common ratio and has the same common difference throughout. A new term is the sum of the previous term and the common difference. An infinite arithmetic progression is always divergent.
Problem statement 2. An open stadium has 20 chairs in the first row. The number of chairs in the next row is 1.5 times the number of chairs of the previous row. For question A, calculate the maximum number of chairs in the row. For question B, which row has at least 505 chairs? Fila table. For the fact, we know that an open stadium has 20 chairs in the first row. The number of chairs in the next row is 1.5 times the number of chairs the previous row. For the idea, first we need to understand the questions. Second, form a geometric progression series. Third, implementing the geometric progression series. And lastly, write a conclusion based on the answer. In learning issues, we can think about which progression is used for the questions. Second one, which formula is used for the calculations. The third one, what is the keywords for the problem. And lastly, forgot to follow the step to solve the questions. Resource needed is from internet and textbook.
Question A. For step 1, we need to understanding the problem. The problem is we need to calculate the maximum number of chairs in the 10th row. Step 2 is planning a strategy. Form a geometric progression series with a fourth term A and factor difference D. We need to determine the number of chairs by using the formula, which is Sn equal to A times R power n minus 1. Step 3 is making a solution. From the question, we got fourth term A 20, common ratio R is 1.5, sequence in geometry progression is 20, 30, 45. With formula Sn equal to A times R power n minus 1. We just to enter the value that we have, and it will become S10 equal to 20 times 1.5 power 10 minus 1. And the last answer, we will get 768.9. Thus, the maximum number of chairs in the 10th row is 768. Question B. Step 1 is we need to understanding the problem. The problem is we need to find the row that has at least 505 chairs. Step 2 is planning a strategy. We need to form a geometric progression series with a first term A and factor difference D, and the least chair is 505. To determine the number of chairs by using the formula, which is Sn equal to A times R power n minus 1. Step 3 is solve the question. From the question, we got first term A is 20, common ratio R is 1.5, chair is 505. Sequence in geometric progression with formula Sn equal to A times R power n minus 1. We just enter the value that we got and it will become 505 equal to 20 times 1.5 power n minus 1. And in terms to find the value of n, we need the sequence that we just has got, we need to times the log 10 and it will become n minus 1 log 1.5 equal to log 505 per 20. And then we move the log 1.5 to the right side and it will become n minus 1 per log 505 per 20 per log 1.5. And then we calculate and solve this question, and the final answer we will get n equal to 9. Thus the ninth row will have at least 505 chairs.
So the conclusion that we can make from this presentation is, based on the answer on the question 1, arithmetic progression, we can conclude that we must use the arithmetic progression method to solve the problem. We have to find the value of chicken left on the total and the total expenses of food. So there are 300 chickens left on the 7th day, and the total expenses of food is equal to 3,150 ringgit. Then for question 2, we can solve this question by using the geometric progression method. The maximum number of chairs on the 10th row is 768. Then for question 2b, we have to determine which row has at least 505 chairs. So by using the sequence in geometric progression, we will get 9 rows for the answer.